Bismillahirrahmanirrahim. We continue our discussion in software engineering and start our next chapter, second chapter, that is the software process. Earlier in the class, we have discussed the first chapter, that was Introduction to the Subject. And in that chapter, we discussed what is software engineering, how it came into being, why it is called software engineering, and how it is different from other types of engineering. There in that chapter, we briefly discussed some of the framework activities, which we can also call the core activities of software engineering, that distinguish software engineering from other types of engineering. So we will take forward those software engineering activities in this chapter and see how those activities form a software process. So in this chapter, we will be discussing what is the software process and what concepts need to be identified, explored, and implemented when you intend to develop a software. So let's proceed with the outline for this chapter. So what are the topics that we are going to discuss in this chapter? Here is the outline in front of you. First, we will be defining what the software process is. So, we will be having an understanding with the topic. Then, we will proceed with what is software engineering and what elements join to form software engineering. So these are different components of software engineering which we will be discussing next. Then we will be proceeding for some of the common phases in software engineering. What are those generic phases? Those phases which are being followed in almost every type of software project. So those phases will be discussed in detail. Then we will be discussing how a software organization achieves maturity in its software process. So what are different maturity levels? We will be discussing here. And then we will be discussing different software development process models. Different models are here, as you can see. We will be discussing every single of them in detail. Why they are required, on what projects they can be applied, what are their benefits, and what can be their drawbacks. So we will be discussing those models in detail in the coming lecture. Let's proceed with the first topic in the agenda, that is how we can define a software process, or what mainly a software process is. So let's see how we can define it and why it is important. When you develop some product or some software or some system. So it is very important to go through some steps. So in order to develop some good quality or high quality product in any sort of engineering, you need to follow some series of steps. Those steps are predefined, which means they set up a roadmap for the developers to help them to create a high quality software that is developed quite well in time. So this roadmap or the plan is known as the software process. Now, you must be thinking, who prepares this process? Now, who prepares it? Generally, the management of the organization, the software development organization, generally decides and adopts the software process with the proper consultation of the software engineers. The process is adopted as per the needs of the software development team who are working on some project. The process selection also depends on the people which we normally call as the customers, or the people who have requested you to develop a software for them. So their choice is also being taken into consideration in order to finalize a software process. So keep in mind, not every process or not every software project may have similar software process. Software process may vary from project to project, or it may also depend on the needs of the customers or also on the requirements of the software engineer. But there are some basic steps. As we just said, software process is a collection of steps. So some of the steps are common in every software process that needs to be followed for every software project. What are those common steps? We will be discussing that in the coming slides. Now, as we have discussed, who develops the process? Then the question is, why software process is important? Software process is very important because a process actually is a roadmap or a plan that gives stability, control, and organization to the software development activity. As if they have to develop a software in ad hoc manner, having no control on the development process. So it becomes quite complicated to handle such projects. If you remember, we had discussed in chapter 1 that initially, when software engineering was not properly implemented, so the software development activities were carried out in quite ad hoc manner. So for that, proper process was required, which helps to bring control and stability to your development task. Now the question is, what are the different steps that comprise to form a software process? The steps mainly depends on the type of the project that is being developed, because not a single process may be suitable for every project. That's what I just said. Single process is not suitable for every software project. For example, you may need to follow different steps to develop a software for an aircraft and a totally different series of steps for a creation of a website. So the software process or the steps within the software process mainly depends on the nature of the projects. So whatever is the project, the process is adopted accordingly. But as I just said, some of the steps within the software process are generalized for every type of software project. So those basic steps need to be followed for every project. What are those steps? We are going to discuss that in the coming slides. So how we define a software process? Software process mainly is the collection of or series of steps that makes a framework for different steps to develop a good quality product well in time. So software process is an umbrella or framework of different activities to develop a software product of high quality delivered in time. Now we have defined what is a software process. The next point that we are going to discuss in the agenda is what actually is software engineering and what are the tools or what is the mechanism or what are the components that form software engineering. So let's discuss what is software engineering. How we can define software engineering? The establishment and the use of sound engineering principles in order to obtain economical software that is reliable and that can work efficiently on real machines. So this is what is the definition of software engineering. Here we need to use sound engineering principles. Why? Because we want to obtain economical software. So economical is the term, very important. Economical, reliable and efficient. So these three are the characteristics of software. Sound engineering principles here means the use of systematic, disciplined and quantifiable approaches for the development, operation and maintenance of software, which means software engineering is the application of engineering to software. If you remember, we discussed in chapter 1 that there are no universal laws governing software engineering, but still some principles, some rules are developed, have been adopted by different software companies in order to develop a reliable, high quality, efficient and economical software. But still there are no universal laws governing software engineering the way they are implemented in other engineering domains. So some principles have been established in order to bring control, stability and organization to the software process. Here, as you can see, software engineering mainly has a layered architecture. As you can see, The bottom of the software product or the software engineering, the bottom level is the quality product. Since software engineering is a layered technology, the base of any engineering is the quality output. So the framework to this layered architecture, in this diagram you can see the base is the quality output. Quality is the product for any engineering work. Quality is an aspect which actually fosters a continuous improvement culture, which ultimately leads to adoption of quite mature approaches to engineering some product, either it's software or any other product. Similarly, the root of software engineering is the development of quality softwares. So quality is the ultimate goal for software engineering. Now, how you can achieve a quality software? So these three are then the pillars in layered form to achieve a quality product. The foundation for software engineering is the process layer. Process is the foundation. You can see the first layer is the process. This lays the foundation for the overall software engineering, and it actually works as a glue to hold different other upper layers together, which ensures the timely development of software having good quality. Keep in mind, quality is quite a vague term here. I'll be defining quality in detail in the coming chapters, but quality means different to different people. So it is quite a vague term. We'll be discussing quality in detail in the coming chapters. For now, keep in mind, the intention for software engineering is to have a quality software, and for this, the base is to have a stable process. Process, as we just said, is a framework for a set of activities to ensure the effective delivery of software products. So software engineering methods provides the technical detail or support for the software development. So next layer is the method. What methods are used to develop a quality software? Here, methods provide the technical details or technical support for the software developments. Method consists of different tasks such as the requirement analysis, design, code, test and maintenance. These different activities form the software methods. The last layer is the tools. Software engineering tools provide the automated or semi-automated support for the software process and methods. Tools here means those developing tools which help you to design, to develop a software. So tools, we can say these are the platforms by using which you can develop your software. For example, you have tools to develop database management systems, you have different tools to develop websites, etc. So tools are the automated or semi-automated support that help you to design and develop your softwares. So these three components, the layered components, actually form the pyramid for software engineering. If you have a well-defined software process in place, having established methods and properly suitable tools to develop a software, ultimately you will get a high quality output. So this is how we characterize the components for delivering a high quality software product. The next point that we are now going to discuss, what are the common phases in software engineering? As we just said, a software process is a collection of different steps to design a software. So here we need to focus on some common phases, those phases which are common to every software engineering project. But since we just said software process may vary from project to project, but some of the steps are common for every software project. So those common or generic phases are to be discussed next. Software engineering process needs to be properly defined. So these are the three generic phases. First phase is the definition. You need to define your process. The steps in software process can be categorized in three common phases regardless of the application of software and its complexity, size, nature. These three phases are common. First phase is the definition. The definition phase mainly focuses on answering all what's. So you need to collect data that help you to answer all what's. Here, software engineer tries to identify what is the problem, what information is to be processed, what functions are to be provided, what design constraints need to be defined, what validation criteria to be verified. So answering all what's that are coming in the minds of software engineering and its team are required to be answered in this phase. So all words would define the system properly and correctly. Here, the major requirements for the project will be identified. So the planning and requirement analysis are the steps which are to be followed under definition phase. The next phase is the development phase. Here in development, the focus is on answering all hows. For example, here the software engineering tries to define how data is to be constructed for the software, how functions are going to be implemented, how design of software will be translated to a working software using some programming tool, how testing will be performed. So here the steps that are commonly followed under development are the software design, software code, and software testing. The last phase that form the generic phase is the support or maintenance phase. Here the focus is on the changes that is brought in software during adoption or adaptations to different environments or through enhancement in software or maybe through error correction. And all this is due to the change in the customer requirements. So the support services or the maintenance is provided when we are required to bring some change in the software. That change may be for fixing some error, that change may be to bring some enhancement in the software, or that change may be to make the software workable on some different environment. The environment change can be of software change or can be of hardware change. For example, the operating system may be changed. Earlier the software may be developed for one operating system, but now the customer requires it to be able to run on some different operating system. So for that you need to make some changes to your software, and for that maintenance is required or support services are required. Similarly, hardware environment may be changed. For example, the processor is changed. So earlier your software was running on different processor. Now if it is required to be run on some other processor, so you need to bring some change. So the change generally is brought in software mainly when the demand or when the requirements of your customer are changed. This phase reapplies the steps as we just discussed for the definition and development, but within the context of the already developed software. You are not going to redevelop the whole software. Rather, we need to bring changes in the already developed software. So for that, developed software, we need to provide the support services. So there are commonly 4 types of changes that are commonly encountered for which the support services are required. So these 4 are the common type of changes that are generally encountered, and for this we need to provide the support or maintenance. First change is the correction. Errors are common in software. Correction is the first type of support that we need to provide. Since errors are common in software, even though if you use some best software engineering methods, still errors are common. So corrective maintenance or corrective support helps to fix the errors in the working software, which may arise due to many different reasons, such as the wrong input by the customer or some mistyping, etc. The next type of support that we can provide is the adaptation. With the passage of time, the original environment, both the hardware environment and the software environment, such as the different types of operating systems, the CPU may get changed. As I just said, user may ask you to make the software runnable on some different operating system or to make it runnable on some other processor. So for that we need to have the adaptation. Adaptive maintenance results in the modification to software in order to accommodate the changing external environment. So if you bring adaptation to your software in order to make it workable on some other operating system or some other processor, so that sort of support will be provided under adaptation or under adaptation. Other type of support that we can provide is enhancement. The more software is used by customers, the more functions or features are required or highlighted by your customers to make the software more beneficial. Those are the requirements which were not earlier provided by your customer. So with the passage of time, they are to identify some more features to be added to the working software. So here the perfective or enhancement support extends the software or enhances it or adds some further features to it which were not earlierly told by your customer. The fourth type of support that we generally provide is the prevention. Changes to software may deteriorate the software, and only then the prevention maintenance is required. Frequent changes are not considered good for any software, as change can be destructive for your software. So prevention is also known as software re-engineering, that ensures that your software keeps on serving the needs of its customers. So preventive maintenance makes changes to software so that it can be easily corrected, adopted and enhanced, so that it is error-free with the passage of time. So these three are the generic phases in any software project. You need to have the definition phase, you need to have the development phase, and then you need to provide the support services, the maintenance phase. They may call it with different names. Those steps can be defined differently, but mainly the intention of those steps would be under the categories of these three major or generic phases. So these are the common phases to be followed on every software project. Next topic that we are going to discuss is the software maturity levels. How a software process gains maturity. We are going to discuss those different maturity levels now. Process maturity is a term that is gaining popularity in the recent years. This actually shows the process maturity level of some software development organization whom they adopt some process. That means how much the software process is mature in some organization. Software maturity level highlights the strength and effectiveness of some organization's process when they are to develop some project. So you can identify different organizations on the basis of these 5 levels, on whatever level it is that would highlight its software process maturity. The more a software process is matured in some software development organization, the more its products will be of good quality. So there are 5 levels for software process maturity. The first level is known as initial. This is the very basic level, or you may say a software company or software organization that just started its functionalities or just started to develop softwares having no proper process in place. So here the software process is not properly defined. No proper process is defined how you would develop a software. And the software process is adopted or developed. The work is rather done in more ad hoc manner. The software development process is generally done in ad hoc manner. So this is the level that we had discussed in chapter 1, when initially when software were to be developed, so people used to follow ad hoc manner to develop or design their programs. So this is the first level where there is no proper software process defined and work is done in some ad hoc manner, and generally the targets are not achieved in this level. You may skip major milestones, and the success of some project at this level is generally attributed to the efforts of individuals. The second level is then repeatable. So when the software organization gains maturity, it brings stability in its software development process. So now the ad hoc manner of working has been now changed to some proper repeatable manner. Now here the basic project management practices are established. In repeatable level, software project practices are established. Work is now not being done in ad hoc manner. Project management helps in tracking the cost, schedule, and functionality of a project. There is a working discipline in place to ensure that the repeat of earlier successes, if you had some in your previous projects, are to be repeated on similar projects in future. So from here, process maturity is started to be gained. Basic project management rules and principles are being adopted, and if you have faced some success in previous projects, those successes are recorded and are repeated on similar projects in future. Third level is known as defined. Here the software process is properly documented. Now you have to define the software process. What are the steps within the software process that you need to follow for different projects? So proper software process is documented. Those steps are then standardized and integrated within the software development culture. Every project has to follow the predefined software process for developing and supporting the softwares. Keep in mind, every level carries the benefits of the previous levels. So level 2 is inheriting the characteristics defined in level 1, and level 3 is inheriting the characteristics defined in level 2. So work is getting mature, but still the benefits or the characteristics that we had in previous level are being inherited in next level. The fourth level is then the managed level, or we can call it as managed. Here the qualitative and quantitative measures in order to measure the effectiveness of software process and the end product is ensured. So now you have a proper defined software process. So in this level, you need to have some measures to measure the effectiveness of the software process, also to measure the quality of the end product. It then also inherits the characteristics of level 3. So software process quality and the product quality is being measured in level 4. Level 5 is optimized. Here, the continuous process improvement is ensured through feedback from your customers. And also, the innovative technologies are to be in place in order to enhance the software process. So, optimized level is the last level, the 5th level, where generally software process is being refined by constant feedback from your customers, and also you need to add latest or innovative technologies to bring improvement or enhancement to your software process. It also then carries the characteristics defined in level 4. So these are the 5 levels for software maturity. Basically, this is the maturity levels for the software process. So if an organization is working to constantly taking your feedback on some project. That means the company is at process maturity level number 5. If properly defined and documented process has been followed in every project, that means the company is at level 3. And if the quality of the process and the product is being properly measured, that means the company is at level 4. So these 5 define the software organizations on the basis of the process, software development process that they follow, how mature that process is. These are the references, the books that you can consult for this course. You can have any of the book to have more insight into the topics that we are discussing. We'll be continuing our discussion on this chapter in the coming lectures as well. That is all for now. In today's lecture, we defined what the software process is. It is basically the umbrella or the framework of series of activities for designing, developing, and testing a software. Then we defined what is software engineering. So, software engineering is the establishment of classic software engineering principles, since there are no universal laws in software engineering, but some principles has been defined by every software development organization that brings stability, control, and organization to your software project activities. What components form the software engineering? Basic intention of software engineering is to have quality output. In order to have quality product, you need to have some stable software process, and for stability of software process, you need to have some sound software development methods using properly defined software tools, development tools. Then we defined what are different generic phases to develop a software. As we said, software process may have different steps, and the steps varies from project to project. Every project may not have same process. But these 3 are the basic phases: the definition phase, development phase, and the support phase. These are the 3 generic phases or common phases which are being followed in every software project. Though the name may vary, but the steps that are to be followed are under these 3 categories. Then we defined what are different levels of maturity for software process. We defined 5 different software process maturity levels, on the basis of which you can categorize one software development organization to or with other. We'll be discussing software process models in the coming lecture. That is all for now. I thank you all.